Welcome everybody to a tutorial video. I'm going to discuss you about free fall. So what is free fall? Free fall is any motion of a body when gravity is the only force acting upon it. The term free fall is often used more loosely than in the strict sense defined above. Thus, falling through an atmosphere without a deployed parachute or lifting device is also often referred to as a free fall. The four kinematics equations form the basis of the equations describing the motion and position of a body in free fall. Of a body in free fall, a body thrown horizontally and a body in projectile motion. For now, we shall focus on a body in free fall. So, for a body in free fall, the following premises are made. Number one, the motion described is along one dimension, that it, the body, is moving along the vertical direction only. Number two, that the body is moving with uniform or constant acceleration imparted to it by the Earth's gravitational pull 9.8 meters per second. Number three, that there are no horizontal forces acting on the body. Number four, that there is no initial velocity. Number five, that the velocity and acceleration are negative to indicate a downward movement. And lastly, the number six, that a negative vertical displacement indicates the object is located below its point of release. So now I'm going to tell you the variables for free fall. Number one is VF, or the velocity final. Number two is the time, or T. Then G stands for gravity, or negative 9.8 meters per second squared. And then Y, because there is no horizontal forces acting on the body.
I'm Fauzia Khalid Mansari, and I will be tackling to you the first two free fall equations. So let's go on to the first. As you can see, the first kinematic equation is Vf is equals to Vi plus At. But since in our free fall equation Vi is equals to 0, then our free fall equation will be Vf is equals to At. But then in our free fall, A is equals to G, or acceleration. Our variable for acceleration is G, and so Vf is equals to Gt. And that's our first free fall equation. The extreme tower ride at Enchanted Kingdom falls freely for 1.3 seconds after starting from rest. Find its velocity. First, let's write our given so that we can easily solve the problem. So our given is 1.3 seconds, and that is time. And next is 9.8 meters per second square, and that is the gravity of the Earth. And then let's write the find, and our find is velocity, or Vf. Lastly, the equation, which is Vf is equals to Gt. This way, our solution will be organized and easy to understand. And now let's move on to our solution. First, let's write the equation. Vf is equals to Gt. Then let's substitute G into 9.8 and T into 1.3, since that is our given. Then let's multiply it. We then come up with the answer 12.74 meters per second. Meters per second is the unit for Vf. Never forget that. So our answer is Vf is equals to 12.74 meters per second. And that's the end of our first example. If an object is dropped from rest at the top of a cliff, how fast will it be going after 4.7 seconds? So first, let's write our given. 4.7 seconds, time, and 9.8 meters per second squared, gravity. Find velocity, or Vf. Our equation is still Vf is equals to Gt. And now, let's move on to our solution. Vf is equals to Gt. Substitute T into 9.8 and T into 4.7. Then let's multiply it, and then our answer is VF is equals to 46.06 meters per second. And now let's move on to our second free fall equation. So as you can see, the second kinematic equation is D is equals to 1 half VF plus VI multiplied by T. But since in the free fall equation, VI is equals to 0, then our equation is gonna be D is equals to 1 half V times T. But to indicate that we are describing the vertical distance traveled by the object, we're gonna replace D into Y, and thus our equation is gonna be Y is equals to 1 half V times T. Now let's reuse the example we've given earlier. The extreme tower ride at Enchanted Kingdom falls freely for 1.3 seconds after starting from rest. How far does it fall? We are given 1.3 seconds for time, 9.8 meters per second for gravity, and 12.74 meter per second for velocity final. We already got the velocity final earlier, and we're looking for distance. So our equation is d is equals to 1 half vf multiplied by t, or y is equals to 1 half vf multiplied by t. Let's go on to our solution. Y is equals to 1 half vf times t. Substitute the variables into their values, and multiply vf times t divided by 2. We then come up with the answer 8.28. Our answer then becomes y is equal to 8.28 meters. A pen was dropped from a building with a 3.3 meters per second velocity. After 3 seconds, the pen landed the ground. How high is the building? Our given is 3 seconds for time and 3.3 meters per second for velocity final. We're looking for distance, and the equation we're gonna use is y is equals to 1 half vf times t. Since now we know the equation, let's now move on to the solution. Y is equals to 1 half vf times t. Let's substitute vf into 3.3 and t into 3. Multiply vf and t and divide it by 2. And we come up to the answer 4.95 meter. Therefore, y is equal to 4.95 meter. And that's the answer for our second example.